Good morning, guys. How are you doing? So in this video, I would like to talk about sequences and series, and in particular, a reoccurrence relationship. And what is a reoccurrence? Well, a recurrence relationship usually uses a term given, a first term, in order to calculate the next term of a sequence. And the reason why it's called recurrence, because every time we have a value, say u1, we instantly get u2, and then we substitute u2 to get u3 and so on. So it's reoccurring for an infinite period, or normally until it tells you when to stop. Okay, where k in this case is a constant. Obviously, the equation might not look like this. You might get un plus 1 equals 2un plus un minus 1. So you might get a series. But bottom line is, we always get an initial value. Say u1 equals some different constant. And we plug it in and we get our entire relationship. So let's look at a nice example, okay? I'm going to take one from a gold paper. This is from question 5 of gold paper 9. So let me have a quick look at it and write down. Okay, so rubbing the board out clean. So the question states this: a sequence x1, x2, x3 is defined by some initial point x1 equals 1, where we have xn minus 1 equals xn all squared minus a constant times xn. So this is quite a large one, and this is for all n greater than or equal 1. So we're looking at, in this case, we'll be sticking to positive values from 1, 2, 3, and so on, where k is a constant. Now, in this question, I want us to find an expression for x2. So really, because we have x1, we just need to replace n with 1. So replacing n with 1, what do we have? Well, this is plus, by the way. We're going to have, so n equals 1. This would therefore be xn plus 1, which is 2, equals x1 squared minus k x1. Now we just replace the values of 1. So x1 equals 1, and hence we get x2. What do we have here? So we're going to have 1 squared, which is 1, minus k times 1, which is 1. And that means we have x2. So now, if we're going to repeat this relationship here, all we're going to do is substitute n equals 2 for x2 to get x3 and so on. So once again, let's do the second. Let's do another problem. Let's try and find x3, okay? x3. To find x3, we need to replace n with 2. So replacing n with 2, we're going to have the same thing. x2 squared minus k times x2. And we already said x2 is 1 minus k. So what we're going to have here, 1 minus k squared minus k times 1 minus k. And lastly, notice that we have a quadratic expression here. So remember, it's a quadratic, so we're not squaring 1 and k. It's going to be 1 minus k times 1 minus k. Okay? Times 1 minus k. And now opening this bracket, we're going to have minus k times 1 is minus k. Minus k times minus k is plus k squared. And opening up this completely, 1 times 1 is 1. 1 times minus k is minus k. Minus k times 1, minus k again. Minus k times minus k, plus k squared. And again, copying the rest. And collecting like terms, so what do we have? We have this part, k squared and k squared is 2k squared. Minus k minus k minus k, minus 3k, and 1 plus 1. And that would be an x3. So now now from the next part of the question, it's gonna say, given also that x3 equals 1, find the value k. So the question might even suggest this. So assuming that, let's call this question C, assuming that the x3 equals 1, what's the value of this quadratic? So what we're going to have here, we're going to have 1 equals 2k squared minus 3k plus 1. So subtracting 1 on both sides, we're going to have 0 here and 0 here. So really, let me just put this on the right hand side. We're going to be left with 2k squared minus 3k equals 0. Now subtracting k outside the bracket, or factorizing the correct term, we're going to have 2k minus 3 equals 0. And hence, our two solutions here, first one would be k equals 0, because k equals 0, and 2k minus 3 equals 0. So plus and 3 and dividing by 2, this will give us k equals 3 over 2. So and here is our solution. So guys, bottom line is, for this recurrence, all you really need to do is just plug in the values, and that's really it. And for reference, this question was obtained from question 5 of a gold paper. Okay, the gold paper is one of the more tricky ones. I wouldn't say it's as difficult as Solomon, in my opinion, from my experience, but hey, might be it. And this is from May 2013. Okay, so if you're looking for this is gold paper, May 2013. Thanks for watching, guys, and if you need any other questions or problems, then just let me know in the comments below. Thanks.